For some, what we're going to do right now might be a review. We're going to remember, review, or learn for the first time, which is fine, this idea about inequalities. And what we have is something that looks like a linear equation, but it's actually going to be called a linear inequality. And these are application problems or ideas that a lot of times we can see in our business world where we're trying to make sure our expenses don't overrun our profits or our revenue. And whatnot. So let's look through and figure out what we do. First of all, we want to simplify this equation wherever we have it at. And sometimes that will require some additional work, which we'll see in the following problems. Second thing we're going to do is we're going to do the addition property to collect all the like terms. And so I'll have a 3x. I'll add 5 to both sides. And now I have 3x is greater than negative 12. Remember, again, what we're trying to ask is for what are all the values of x that make that statement true? Still want to isolate x because I want to multiply to iso. So I'm going to divide both sides by 3. And I get a solution that's true for all x's that are greater than 4. And the last thing is I want to appropriately express the solution. And the two ways we need to appropriately express this is one in the graphical form. So I draw a number line. I find my pivot point or my point of interest, which in this case is negative 4. So I can just write that wherever I need to write that at. And this tells me all my solutions, those points that are of interest to me, are greater than negative 4. So I'm going to shade in all those answers in that direction, with one additional caveat. This point right here at negative 4, is that a solution point? Is that negative 4 itself a solution? No, it's not. So I need to make sure I identify it as such. And there's a couple of different ways that you might see useful doing that. One way is some people put a circle right there, but will not fill in the circle. That tells me that 4 is its limit, or negative 4, but negative 4 is not a solution. You also might see some people write it this way. Well, they're going to put a little bit of a bracket on it like that, and then all the solutions going that way. So both of those represent all the solutions greater than negative 4, but not negative 4. The other way that we need to write this is in interval notation, which means is what's the beginning and ending points of all my solutions? Well, I can kind of see it from the graphical form. I know that my beginning point really is negative 4. And my ending point? Well, this goes all the way to infinity. So there's kind of my solution a little bit. However, I need to also designate is negative 4 a solution or not. In this particular case, it's not. So I'm going to put a soft bracket on the negative 4. And then infinity, since we can't nail it down to a very precise location, we're also going to give it a soft bracket. And we'll show you later what it means if we use a different type of a bracket. But for right now, these soft brackets represent numbers that are not the exact solution, but every number that's above that is a solution. Sorry, I tumbled over my words a little bit. The other thing too is this does look like a coordinate point, or at least coordinate notation. And based on the context of the problem, we will understand that it's representing interval notation.